All right, let's do this. This is Elliot with your GRE question of the day. We're going to be looking at exponents on the quant section today. So buckle in, get excited, because your quant score is going to be exponentially better in just a few minutes after we take a look. Sorry, I couldn't help myself. After we take a look at the question we're working on today. It's this one. So I'll ask you to pause the video and just give this a first look and see what you recognize, what's familiar for getting started working on this one. If you're empowered to do so, keep right on going and solve it. And in either case, then you can unpause me and we'll walk through it together. All right, question of the day says, if 2 to the n is equal to 3, what is the value of 2 to the 2n plus 3? So what do we recognize? Well, I gave it away in the open there. We're looking at exponents. So hopefully you are recognizing that the number properties rules that deal with how to simplify expressions that have powers that have exponents in them are probably going to be at work on this question. But I feel like a lot of us probably got stopped in our tracks in terms of knowing what to do next when you see one that says if 2 to the n equals 3. Because, well, first of all, there's a variable in there, so I can't start making any calculations. And secondly, if I stick to like the simple integer, the whole number powers that I know, 2 to the first, 2 to the second, 2 to the third, I'm never going to get anything that's equal to 3. So maybe that raised a red flag for you. And that's good if you're feeling a little confused. We'll subtract the confusion, but know that your skills for pattern recognition are actually perfect in this case. We just want to connect when we recognize a pattern like this. I have an expression with exponents, but I don't see what math I would reasonably do next with it, that there is an alternative way we need to go about solving this one. And in this case, what I'll recommend, what you got to be ready to do when you see some funky algebra or a funky expression with exponents in it, is we're not going to do like normal algebra where we try to isolate that variable. Instead, we're going to do a secondary style of algebra, but one you'll probably need at least once or twice on test day, where what we want to do is make expressions look like one another. Okay, what am I talking about? Ooh. What am I talking about here? What I am talking about is trying to say, I'm going to start from 2 to the n, but the value that I really want is 2 to the 2n plus 3. So what I would challenge you, what I want you to be asking yourself is, how can I make the original expression look like the second expression, the 2 to the 2n plus 3? In other words, what steps of math would we take to transmogrify that one, to just change that one expression into the other? Okay, and we're going to call on two extremely valuable rules about exponents in order to do this. So if you've already reviewed this, if you've been studying for a while and you know your exponents rules, then hopefully what I'm going to say next is going to sound super familiar. If not, that's totally cool. But these two rules that we're about to go through are ones that you should have memorized if you want to maximize your quant score on test day. Okay, so first, we have the just n by itself in the first expression. In the second one, it's 2n, it's multiplied, and it's plus 3. So let's let order of operations work for us. We know that we're going to want to multiply before we add, so let's worry about the plus 3 in a later step. Let's first say, how would we go from just n in an exponent to 2n in an exponent? If we want to multiply by 2, how do you do that with exponents? You don't just multiply. But instead, if you're multiplying within an exponent, that actually comes from, where does it come from? It comes from raising an exponent to another exponent, okay? Double exponent. In other words, if we take 2 to the n, and I'll put parentheses so we don't get confused, and I square that whole thing, raise the whole thing to the power of 2, that is when the rules tell us we multiply the exponents together, and it becomes 2 to the 2n. Okay? Now that we have 2 to the 2n, how are we going to get the plus 3 into the exponent? This is where a lot of really bright students still get confused if they haven't had enough repetition to build up some confidence on these exponents rules. When we add our exponents together, it doesn't come from adding the numbers. It comes from multiplying by another 2 raised to a power. Okay, so I need that same base, and then that's what's multiplied together, and that's what's going to result in the adding. Crystal clear when I explain it, right? Of course not. Let's take a look at what I mean. So what I'm saying is we take 2 to the 2n, and we are going to multiply that by another base of 2 with 3 in the exponent. So it's good we have these two different rules here. We're real clear on the difference, that when I have two bases, it got to be the same base, meaning that 2 is the number being raised to a power. That's the base. When we have these two bases being multiplied together, we simplify by making one base with the exponents added together. So 2 to the 2n times 2 to the third equals 2 to the 2n plus 3. All right, now let's call a quick timeout. Before we move on to solving this question, let's recap again these two rules, super, super important. When I have a double exponent like we had over here in our first example, double exponent on one base, that is when the exponents get multiplied together. In our second example here, two bases being multiplied by one another, that is when we add exponents together. Critical for you to execute these rules correctly and not mix them up on test day. Okay, so now that I know how to get from 2 to the n to 2 to the n plus 2 to the 2n plus 3, we can now come back and say, how do we proceed with solving? Well, we haven't used all the information they gave us in the question yet. So we know that 2 to the n is equal to 3, the question tells us. So now it's a matter of some simple substitution. All right, so I'm going to rewrite just as I have in that middle line, but instead of 2 to the n, I'm going to write 3 in place of my 2n, and that's what's going to get squared. And we all know that 3 squared is equal to 9. And now 9 is what's going to get multiplied by 2 to the third. Okay, same math that we have from the line above, just substituting the 3 in for the 2 to the n. And 2 to the third, you should know at least your little powers of 2, it's worth it. Otherwise, we know 2 to the third means multiplying 3 2's. 2 times 2 times 2 is 8. Great job. And 9 times 8 makes 72. So 2 to the 2n plus 3, that value is 72. And we're done. Answer choice C is correct. Great job, team. Way to hang in there and push through what looked like a tricky one. I hope you're feeling good about the takeaways, recognizing this secondary style of algebra. Sometimes instead of isolating a variable, we just want to make two expressions look alike. And of course, knowing our super valuable exponent rules, making sure we have them dialed in on ready recall when we get to test day. I hope you'll join me right back here tomorrow for another GRE question of the day. And in the meantime, if I can get it out cleanly, happy studying.